So in this video, I just wanted to emphasize the importance of using your periodic table in your exam. The periodic table will be printed at the back of the exam paper and it's going to look exactly like this. And there's so much information on your periodic table if you just know how to use it properly, okay? So the first thing I want to draw your attention to is just this key, okay? It tells you how to read your periodic table. And it tells you that the relative atomic mass is at the top, okay? So that's telling me that this number here on beryllium is the relative atomic mass. The next thing is the atomic symbol. So the atomic symbol for beryllium is going to be Be. The next thing is the name. So again, it tells me that the name is beryllium. And then it tells me that this number at the very bottom is the atomic number, which tells you the number of protons. Okay, so you could get a question asking, what is the atomic number of magnesium? And by using your key, you'll see the atomic number is the bottom number, and the bottom number for magnesium is 12. What is the atomic number of carbon? 6. What is the atomic number of potassium? 19. Okay, so the atomic number is the bottom number, and it tells you that on your key. They could ask you, what does the atomic number tell you about an atom? It tells you the number of protons. Again, that's there for you on your periodic table. The atomic number tells you the number of protons. Or they could ask, how many protons does beryllium have? It's got an atomic number of 4, so it's got 4 protons. How many protons does magnesium have? It has got 12. How many protons does calcium have? It has got 20. They could ask you, what is the mass of lithium? You see that mass is the top number. The top number for lithium is 7. Therefore, the mass of lithium is 7. What is the mass of carbon? The mass of carbon is 12 because that's the top number, okay? So pay attention to this key. It tells you what the numbers mean, and that will help you answer some of the questions, all right? Other thing that you should be doing, okay, is you should be filling the following into your periodic table. You should do this right at the start of the exam. Just fill in these little things, and then you'll have them to refer back to, okay? So I would draw in my line. All right, I would draw in my line, and I remember that metals are on the left-hand side and non-metals are on the right-hand side, okay? So you've got metals on the left-hand side of that line, and you've got non-metals on the right-hand side of that line, okay? The other thing I would fill in was I would remind myself that the groups go down, so I'd put an arrow going down, and I would write group on it, and that the rows going across are called periods. And it's really important to remember that the first period is here with hydrogen and helium. So next to hydrogen, over here on the side, I would write period 1, and I'd have an arrow for myself going across, so I know that this is period 1, which would make this period 2, okay? And the type of questions that you could get on that, well, they could say to you, name an element from period 2. And you would need to know that this is period 1, this is period 2, and then you can pick in any element from lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, or neon as an element in period 2. They could ask you name an element in group 6. So you know that the groups point down, you go over here to group 6, and you could say oxygen, sulfur, selenium, any of them, okay? They could put that together, and they say name the element that is in period 3, group 5. Okay, so I go to my group 5 and I need to go to period 3. So this is period 1, okay? This is period 2. Period 3 is phosphorus, okay? And it's very easy if you're doing group 5, period 3, to go, this is group 5, 1, 2, 3, and end up here with arsenic, okay? But you need to remember that period 1 is hydrogen and helium. Nitrogen is in period 2, which makes phosphorus period 3, okay? So remember, this is period 1. Remember, periods are the rows across, and then groups are going down, okay? The other information you can get in terms of groups, okay, they give you the group number on your periodic table, and that number corresponds to the amount of electrons in the outer shell, okay? So I would write that for myself. I would say group number is the same as number of electrons in OS outer shell. Okay, so what that tells me is if I've got potassium in group 1, it has 1 electron in its outer shell. I've got phosphorus over here in group 5, it's got 5 electrons in its outer shell. I've got chlorine here in group 7, 7 electrons in its outer shell. And that information is really important, especially if you're asked to draw covalent diagrams, so those dot cross diagrams, and they'll say draw the outer shell electrons only, and they might say draw Cl2, and you would need to know, okay, how many electrons does chlorine have in its outer shell? Oh, it's in group 7, it has 7 electrons in its outer shell. Okay, so that group number tells you the amount of electrons in the outer shell. Okay, because you know how many electrons are in the outer shell, you know how the elements are going to react. Okay, if it's got 1 electron in its outer shell, it will lose 1 electron, and if it's got 2 electrons, it will lose 2 electrons, and if it's got 3 electrons, it will lose 3 electrons. Okay, if it's got 4 electrons, okay, it doesn't lose or gain electrons. It's always going to share, okay? If it's got 5 electrons in its outer shell, rather than losing 5, it will gain 3. If it's got 6 electrons in its outer shell, it will gain 2. If it's got 7 electrons in its outer shell, it will gain 1. If it's got a full outer shell, it doesn't need to react. So I'm going lose 1, lose 2, lose 3. I'm skipping over group 4 because they always form covalent compounds and they don't lose or gain electrons, they always share. So I'm going lose 1, lose 2, lose 3, then gain 3, gain 2, gain 1, and then these guys are unreactive, okay, because they've already got their full outer shells. If my group 1s are always losing 1 electron, then they always have a +1 charge. Group 2 is +2 charge. Group 3 is +3 charge. Okay, my non-metals, they gain 1 electron, they have a -1 charge, gaining 2 is -2, gaining 3 is -3. Those charges are so important. Please put them on your periodic table at the start. You're just going 1, 2, 3, skip group 4, 3, 2, 1. Plus and then minus, okay? And what you'll see is the metals, which are on the left-hand side, they're always losing electrons and forming positive ions. And then on the right-hand side of the line, you've got the non-metals, which are gaining electrons and forming negative ions. Okay, and there's lots of questions where you need to know the charge on something. Look at your periodic table, you see what group it's in, that tells you the charge on the ion. Okay, really, really important that you know what charges are on the ions. Okay, the last thing I would do if I were you, I would circle the following elements. I'm going to show you why in a second. I would circle fluorine and chlorine and bromine and iodine. We never use astatine, so I'm not going to bother circling it. All right, I would circle all of my group 7s. I would circle oxygen, I would circle nitrogen, and I would circle hydrogen. Okay, and the reason I'm circling all of them is because they are diatomic. I'm going to show you the importance of that in a second. Okay, they are all diatomic. Okay, I would also remind myself that hydrogen is a non-metal. Okay, because it's over here with the metals, but it is a non-metal. So at the start of the exam, I would just fill in those few little things, fill in the charges on the ions. Okay, it's so, so important. Okay, remind yourself that groups go down and periods go across, and that this is period 1 with hydrogen and helium. Remind yourself the metals are on the left, non-metals are on the right, and circle those 7 elements: hydrogen, nitrogen, oxygen, and then the halogens. And I'm going to show you why now. So I've written down some chemical reactions for you, and I've written the word equation, and we are going to look at the symbol equation together. Okay, so the first one, carbon plus oxygen goes to carbon dioxide. I've told you in each case what the formula of the product is, but what I want you to be able to do is write the formula of the reactants. Okay, in order to do this, you need to look at your periodic table. Okay, carbon is an element. I need to find out what the symbol for carbon is. So I look at my periodic table and I see that the symbol for carbon is C. Therefore, when I want to write it as a symbol equation, I just write down C. Then I go to oxygen. Then I go to oxygen, which is also an element, and I look on my periodic table and I see the symbol for oxygen is O. But then I notice that O is circled, and I remember that instead of just writing down O, I'm going to write down O2. All of my circled elements I have to write as diatomic molecules. Okay, carbon wasn't circled, so I just write down C, but oxygen was circled, so I'm writing down O2. Now I've got carbon plus O2 goes to CO2. Okay, what I am not going to do is look at my product and try and work backwards, and you'll see this below. Okay, the next one I've got is carbon plus fluorine. Carbon's an element. What is the symbol for carbon? On the periodic table, the symbol is C. I write down C. Fluorine is an element. What is the symbol for fluorine? I go to my periodic table and I write down F. And then I see that fluorine is circled, and I know instead of just writing F, I have to write F2. Okay, now we see if you add C and F2 together, you're not getting CF4. Okay, so this is when you have to go back and balance. But the important thing to remember is if they give you the product, you can't just write carbon and then F4. You're not just splitting the product in half. You need to have a look at your periodic table and write the symbols for the elements, ignoring what you've got for the product. Okay, so carbon is just C on my periodic table. Fluorine is F, but it's diatomic. I've circled it. It's F2. All right, now I'm going to try and balance this. I've got one carbon on each side. So that's fine, it's already balanced. But fluorine, I've got four fluorines on the right and only 2 on the left. When I am balancing, I do not use small numbers, okay? The small numbers represent the formula, and the formula I am not going to change. Instead, I'm going to use big numbers. If I've got 4 fluorines on the right and only 2 on the left, I need to put a big 2 here. That gives me 2 times 2 is 4 fluorines in total, and now it is balanced. If I do the next one, hydrogen, it's an element. What is the symbol? The symbol is H. And again, I see that it's circled. So if it's circled, instead of just writing H, I need to write H2. Oxygen is an element. So on the periodic table is O, but I've circled it. So I'm not writing O, I'm writing O2. Okay, I can see now that I have got 2 hydrogens on the left and 2 on the right. That is balanced. But with oxygen, I've got 2 on the left and only 1 on the right. The temptation is to come over here and put a little 2 there. You cannot do that. You cannot change the formula, so you cannot use small numbers. All right, you write the formula of each thing individually, and then if you need to go back and balance, you do, but you don't do it with small numbers. So I've got 2 oxygens on the left. If I want 2 oxygens on the right, I need to use a big number, and I can't just stick it in here in front of oxygen. It has to go at the very front. Okay, so 2 oxygens, and now I've got 2 oxygens. But by putting that big 2 there, I've also changed the number of hydrogens. I've now got 4 hydrogens on the right and only 2 on the left. So I need to put a big 2 here so that it balances out. If I do the next one, carbon plus hydrogen goes to methane, okay? I'm told methane is CH4, I'm ignoring that, okay? That doesn't help me write this side. I'm going to do this side completely separately. Carbon on the periodic table is C, so I put in a C. Hydrogen is H, but I've circled it, so I know I'm writing it as H2, not as just H, okay? I go back to balance. I've got 1 carbon on each side. That is fine. But I've got 2 hydrogens and then 4 hydrogens. I need 4 hydrogens on this side. So I put a big 2 here and I balance it. The next one, I've got nitrogen. I see nitrogen on my periodic table. It's here and it's circled. So instead of just writing N, I need to write N2. Hydrogen is H and I know it's circled. So I'm going to write H2. Okay, so I'm given ammonia as NH3. I'm not using this to write the left-hand side. Okay, I go to my periodic table. I see the symbol for nitrogen is N. I see it circled, so I write N2. I see the symbol for hydrogen is H. I see it circled, so I write H2. Then, when I've got my equation properly written, I go back and balance using big numbers. Okay, so this one is a slightly harder one to balance. All right, I've got 2 nitrogens on the left. I've only got 1 nitrogen on the right. So that tells me I'm going to need to put a big 2 here. Okay, so I've got 2 nitrogens on each side. Remember, I'm balancing with big numbers. I cannot use a small number. All right. In doing so, though, I've also changed the number of hydrogens. I've now got 2 times 3. I now have got 6 hydrogens on the right-hand side. I need 6 hydrogens on the left. I've currently got 2. If I multiply by 3, then I've got 6 hydrogens on the left, 6 hydrogens on the right, 2 nitrogens and 2 nitrogens. Okay, I want you to have a go at these 3 yourself. So I've given you 3 other word equations. I need the symbol equations. I've given you the formula of the product in each case. I just want you to write the formula of the reactants and then balance it. Remember, when you are doing the left-hand side, you just ignore the right-hand side and just do it separately. What's the symbol for sodium? Write it down. What's the symbol for oxygen? Write it down, and then balance afterwards. When you're writing down the symbols, you're just looking at the periodic table, and if it is circled, you're writing a little 2 after it. Have a go with that. Have a go at those 3. Press pause and then press play when you're ready to see the answers. So I've written the symbols, but I haven't balanced yet. Okay, sodium on the periodic table is Na. It's not circled, so I'm not putting a 2. Oxygen on the periodic table is O. It is circled, so I am putting a 2. Okay. If I want to go back and balance this, all right, I see that I have got 2 oxygens on the left. I've only got 1 oxygen on the right. I can't just add a little 2 there. I need to use big numbers, and the big number needs to go at the very start. So I'm going to have to put a big 2 here. So I've got 2 oxygens on each side. In doing so, I've changed the number of sodiums. I've now got 2 times 2 is 4 sodiums. So I need a big 4 over here to give me 4 sodiums. Okay, I'm always using big numbers to balance, never small. The one underneath, lithium, on the periodic table has a symbol Li. It's not circled, so I don't write it as Li2. Oxygen is O. It is circled. I write it as O2. Okay, again, I've got 2 oxygens on this side. I've only got 1 on this side, so I use a big 2. 2 times 2 gives me 4 lithiums, so I need a big 4 over here. The last one, lithium again, symbol is Li. Chlorine on the periodic table has a symbol of Cl, and chlorine is in group 7, and it's one of my circled ones. So instead of writing it as Cl, I write it as Cl2. Okay, then I go back and balance. 1 lithium on each side, so that's fine. But 2 chlorines on the left and only 1 on the right. I can't just stick a little 2 there. Instead, I have to put a big 2 at the front. Now I've got 2 chlorines on the left, 2 on the right. But by putting that big 2 there, I now have 2 lithiums. I need to go back and put a big 2 here. So I've got 2 lithiums on the left and 2 lithiums on the right. Okay, we're going to do lots more work on writing and balancing equation in year 11. But for your exams, just make sure that you can write the formula of elements using your periodic table, which is why it's so important to circle the diatomic ones, and then be able to go back and balance those equations.